So I'll be talking this morning about the application of geospatial technology in a water utility, and specifically the company in question, Ghana Water Company. Okay, so briefly to walk you through what you should expect. I'll do a bit of introduction about Ghana Water, talk about its mission and vision, and also the mission and vision of the department itself. And I'll also talk about the role of GIS and hydraulic network modeling in GWCL. I'll mention a few challenges that we have and how we have dealt with it, and the application of GIS itself in our particular setting. And I'd also touch on the future of GIS, where we intend to move from here, and then I'll conclude. So a brief about Ghana Water Company. We are a utility company, and we are solely owned by the state. Okay. Our mandate as a company is to provide potable water to the urban community. And for this, we abstract water, we treat it, and then we transport this through our transportation mains up until our distribution points, where it is delivered to the various homes and customers that we have. And of course, we also deal with the billing and then collection of revenue that accrues from the use of this service. As a company, we have presence across the country, and we operate 90 systems, water systems, and we provide water to a little over 13 million consumers nationwide. This we do through a network infrastructure that measures a bit over 12,000 kilometers. And from this network, we have a little over 780,000 connections of customers connecting to this network. We have a staff strength of a little over 5,000. And annually, we are producing 320 million cubic meters of water as a company. From this figure, we have a non-revenue percentage of 39. And administratively, the whole company is being run or segmented into 13 regions, and then there are 2 more administrative ones that deal with the production. And within these 13 regions, we have a total of 13 districts that see to the day-to-day running of our operations. As a company, we have a vision of being a world-class utility. So we put in a lot of efforts, make sure that over the years we are growing ourselves and better our operations to make sure that we achieve this vision. As a mission, we are committed to meeting the increasing demand that we are faced with. And we have a few core values. One has to do with the quality and excellent customer service, urgency in service delivery, continuous improvement and innovation, health and safety of our stakeholders. And then we have also high ethical and professional standards. So the GIS department or unit falls under the umbrella of a bigger department. I'll briefly take you through the structure. But we also have a vision department, and our vision is to be a technological wheel that drives the company towards its operational and commercial excellence. And we intend to do that by leveraging on the power of technology, specifically geospatial technology, to expand and shared management, information, and critical thinking, and also to improve business processes, systems, and inform decisions. Like I briefly said, our department houses a couple of units, of which the GIS and hydraulic network modeling forms one of them. We have other departments as well, like the non-revenue water and metering and instrumentation. We have an IT unit, and then also a research and development unit as well. So as you can see, we have a structure which has me here at the head office, and I basically oversee 13 other regions and assist in their GIS operations and functions there. Overall, our goal as a unit is to provide a geographic framework that would provide or serve as a tool to support decision-making in the company. And how are we doing this? We are trying to make it possible for Ghana Water to know locations and the conditions of all our strategic assets. And we are also developing applications to help achieve this goal, and applications specifically GIS related and IT based. We also try to develop hydraulic network models, and that would help us in designing our water networks and also to support its operations. We also help to systematically measure and help reduce non-revenue water. And as we go on, we'll see that as a company, this is very key to us, because we are delivering a service and we are giving a product out. And for us to be financially viable and to be in business, we should be able to account for everything that we produce. But like you saw in my previous slides, there are some lapses in there. And to this, we lose about 39% of the water that we produce. And it's one of the key areas that our unit tries to intervene to help pull this number down to appreciable levels. So all of these things, developing plans to aid flow control and effective management of the districts. Ultimately, once we have all these things done, we are sure that it then leads us to increase sustainable potable water service delivery to our customers. And ultimately, we can also increase our revenue collection as well. We do a bit, we also do something on hydraulic network as I mentioned, not just GIS, because the two sort of work hand in hand as well. So we provide a basis where we can sort of simulate the network and sort of help us know, for instance, how the network would behave if we were to do certain changes within the network, how does it affect our customers? How does it affect water in the system? The hydraulic network modeling usually helps us to achieve this. We also use that for planning as well. But one would want to ask that, what is the relevance of GIS in all of these? As a company, we've chosen to include GIS in our operations, mainly for some of these key benefits, that it helps us to analyze the geographical characteristics that we find within our working environment. It helps us to know how it interacts, or how it's related to our operations, the water that we are serving to our customers. For instance, how is the terrain impacting on Ghana Water, sending water to its customers that probably have their houses located probably on a hill or somewhere far from the network. The GIS also helps us to model alternative processes that helps or aids in our management and operations. So for things that ideally you'd have to go to the field to do manually, and just imagine that you have to sort of iterate these scenarios on the ground several times, it does involve a lot of work. But using GIS and network modeling, hydraulic network modeling, you're able to simulate all these things within a computer and software environment. And if we are doing this based on very good data, you are bound to have results that are very, very close to what happens in the real life. Generally, it helps us to manage our assets. So we put all of these benefits together. It makes us as a company better informed when we are taking decisions. These decisions we can also do very, very quickly, because then we have the benefits of such a system that helps us to create real world simulations within the software environment. As a company, as I mentioned, we are bedeviled with a few challenges. We have aged assets that we are running. Indeed, when it comes to the assets that we use, our pipelines, our ponds, our valves, these are things that have been in the system for quite a long time. And as they wear and tear, it also impacts their efficiency, and it affects our output as a whole. Inadequate production capacity. This is also one thing that that we have to deal with the growing demand. We have our plants designed to serve a specific number, or if I should say, a number of customers. And as we are growing, the city keeps growing, you have people coming in. It's something that if we are not able to catch up, it also affects our ability to serve water to all of the places that we are mandated to. Currently, we are all aware of the challenges that we have with Galamsey activities across the country. And this also affects us as a company, because we source our raw material, which is water. We are sourcing it from our river and water bodies. And these, as we all know, are highly polluted these days. And it also affects quality, which means that if we are supposed to be drawing, extracting water from these sources, it requires us to do a lot more of treatment, and that comes with at a cost as well. And non-revenue water, like I spoke about, we lose water along the network from production all the way down to the consumer. We are losing close to 39% currently. And in the midst of all of these, we also have a tariff regime that is not really realistic to support investments or recover capital costs that we are putting in our operations. So all of these things are challenges that we grapple with as a company. However, when it comes to the issue of the GIS, we can talk about how we use GIS, especially to help in reducing the high non-revenue water, and probably also for monitoring our assets, which gives us an idea of assets that require replacements or as you may know. So I'd like to focus on some of the challenges that we have had as a unit to address using GIS. One has to do with the absence of a spatial decision support system. So when we first came in as a unit, there was actually, if I should say, we didn't have any GIS then at the time. All that was available was just few paper drawings, as-built drawings, which was being used at the time. Information on the distribution network also at the time was a challenge, because you have this knowledge of the network residing in individuals. So you could find one person who was very knowledgeable in the network, and that the problem with such a thing is that one person exits the company, then he moves along also with this information. So there wasn't any central repository where information on the network was stored and could easily be retrieved. And because this was also not available, analyzing the network was also a challenge, because then the data that was needed to do that was not available. And for these as-built drawings that used to assist also, you would find out that most of them were exposed to very harsh conditions of the weather, because again, they weren't being stored very, very well. So you'd have things like this. Virtually what we had there was more or less like a drawing office, and they dealt mainly with the hard copy drawings. So how did we deal with this? Indeed, it was a lot of work. We had to try as much as possible to pull together all the available drawings at a time, scan all of these drawings to make them, if I should say, digitalize them so that it's more easy to handle. So after storing, we have archived them. And then based on the kind of information that we could extract from these drawings, we had to also design a database model that could help us extract the kind of information and then store it as well. The scanned images now also went through a process of georeferencing, especially with those that had grids on them. That way, it was a lot more easier to georeference them. And then we did more of like a on-screen digitizing to now vectorize the images that we had in the system. So we did this consistently, and then we sort of built up a database, which we now used subsequently as a reference for validation. So we'll take that information and then we'll go to the field to verify this information. So what we had already collected served as a guide. Not only did we do this alone, but then we also, like I mentioned, there were very key people who had good knowledge of the network. So during field validation, we'll now actually capture the location of these pipeline assets and the appurtenances that we had within the distribution network. And from this, we gradually built a network, a spatial database of the pipeline network. So currently, if I should say, back in the days, we started then in Accra, mainly in the 3 administrative regions. We had the Tema region, we had Accra East region, and also we had Accra West region. Collectively, from our efforts as a unit, and also those on the field, were able to capture a lot of information out there. And gradually we extended or expanded from the Accra regions. And I can confidently say that now we have GIS presence across the country in all of our administrative regions as we speak. So this is was one of the first things that we had to overcome, trying to build the spatial asset database. And this, we are collecting information on both our buried and then landed assets. So pipelines, valves, washouts, end caps, all the appurtenances that define the distribution network. We had to collect. We also collect information of our office locations, our pay points, and other landed assets that we had. The pipeline database is very critical, it is very essential, and it forms the backbone of all other subsequent solutions that we have used GIS to solve. So aside the network itself, I can also talk about leakage management. Again, this is another area that GIS was used or has been applied to try and then address the issue that we have with leakages within our system. So prior to GIS then, network management was usually or is usually done in a ad hoc manner. There wasn't any systematic approach per se. Again, for the lack of any spatial data, we couldn't, or the company at the time couldn't even build their network or distribution operations on any sound hydraulic support system. So again, it's done based on experience and more of a trial and error approach. When it comes to leakages as well, there wasn't any conscious effort then to go out to look for leakages and try to repair them. So how did we use GIS to address the situation? So we can talk about it probably in twofold. One is what we call DMAs, district metering areas. So you would know that or appreciate that we have quite a huge network. And just imagine looking for leakages within the network, considering its size. How would you approach it? And we did this using the DMAs. And basically what the DMA does is that we take the network and then we try to segment it and zone it into smaller and manageable areas. And we do this by taking the network into consideration. Clearly, we couldn't have done this in the absence of a GIS, because now to achieve this, we need to have a GIS system in place that tells us where these pipes are to start with, where the valves are within the network, where do we have all the necessary appurtenances, the meters, all of those things. We need to have them first. So we could build on it as well. So the DMA basically takes an area and looks at the pipes that define that area. And then we try to isolate the area by closing valves that allow water to move into the area. Or in some cases, when it's even necessary, we try to completely remove a line. The whole objective is to make sure that we are able to measure or know exactly which lines are bringing water into the system. Once we know or we're able to identify these pipelines, we are also able to meter these pipes. Then we know exactly the amount of water that is being pushed into this area. When we're able to measure this, it also requires that we have almost all of our customers metered as well. So at the end of the day, what we can do is we can do some sort of a water balance where we can compare the cumulative consumptions of all the customers within that DMA, for instance, to the flow readings of the bulk meters that we are placing on the inlets and outlets of this DMA. Once this is achieved, we can also move on to now, after doing the water balance, you can now have a very fair idea of how much water is being lost. And then from that point, we can take up other steps like the active leakage search and repair to zone in on some of these places that would help us deal with reducing non-revenue water. So that is for DMAs. And then also for leak management. All these things culminates into a higher non-revenue water figures. So to deal with it, we have to find a way of, first of all, try to mitigate the losses we have in the system. So using the DMAs is one. Another approach is leakage mapping. And for this, what we do is we do an active leakage search and repair. What this means is that for a specific district, we would have people who go out to look for leakages. And this is a proactive approach. We don't want to wait for people to report before we act. So we adopt a more proactive approach where people come in, where we go out to look out for these leakages. And then once you find a leakage, you are required to map it, first of all. And secondly, if this leakage is something that can be easily repaired there and then, we do it. Otherwise, you would have to get back and then what? And then we have a team that would go out with the necessary materials also to go and then address that leakage. So if you see on your right side, we have a map that shows various, we have two colors actually, red and then one green within our pipe network. The pipe network is symbolized with the blue lines. So the red dots usually shows, it shows the leakages, and then the green one shows leakages that have been repaired. So we have pending ones and then those that have been repaired. And this is one way that we use GIS to address non-revenue water. Because aside just doing this, what it does also or provides is to improve supervision. So in the case where you wouldn't know what a specific person will be doing on the field, we have a benefit of a system that would show us leakages that have been identified within the network and have either been repaired or are pending repairs. And if you have your supervisors and then your superiors in the know of this information, it whips people into line and ensures that they are delivering on what their mandate or their role is within the network.
All right. Hello, Mr. David.
Yes, please.
Yeah, sorry to interrupt you. It's just that we are 5 behind time, and if you could just wrap
okay,
up.
Okay.
Yeah.
Okay. So let me probably just run up to customer care, and then I'll just do a short demo, and then I'll be done. So when it comes to customer care, we've also applied GIS. One, we had challenges knowing where all of our customers were. Usually, this information also resides with the meter readers. They are the ones who know where our customers are. In their absence, you couldn't really be able to trace all of our customers. We also had challenges of our meter readers sometimes not going to read meters, and they do what we call armchair meter reading, where they try to estimate or give readings to accounts without necessarily going to the customer premise to go and then read their meters. So what we did to address that issue, for instance, is that we started off with a consumer survey that sort of captured or swept the whole area. And then this helped us, one, to map our customers It gave us also an idea of who our prospective customers would be. And it helped us a lot to also weed out illegal connections at the time. Based on that information, we now have location of our customers. It's a lot more easier to provide information on GIS equipment to meter readers. So you don't have to keep one meter reader, for instance, at a location for a very long time. It's a lot more easier. When you bring in a new person, he has the benefit of these locations that we have in our system to trace and then go to the customer location to read their meter. And when it came to like the armchair meter reading, for instance, we implement some geofencing also into our meter reading application, which requires that for a meter reader to be able to read and upload a meter, it has to be within a specific range from the customer meter to do this, thereby making it impossible for them to be at a different location and then be churning out readings, consumption readings. I can talk about other solutions that we have, for instance, inputs, helping to locate vantage points where we can put meters to measure the input volumes that we are bringing into the system. This is an example of a 3D model of a Barikesi reservoir that helps us to determine the level of sedimentation in there. That could help us to know whether the dam itself is silted and needs to be dredged or not. This one has to do with using the elevation data that we have as against our customer billing records. And it gives us an indication of the correlation between the relative elevation of customers and their water supply as well. Since we are running out of time, let me just show one more. Can you see my screen, please?
Yes, we can.
Okay, so this one is an example of the leakages. Okay, so we have a web map that has been developed, and it does a similar thing like I explained before. We basically map the location and the status of the leakages, whether they have been repaired or not. And then we have a dashboard that gives us a summary of the activities. For instance, for here, we have a leakage per material, so that it gives us a summary of which materials. Yep.
Hello, sorry, we can't see the web. I think it's we can't see the dashboard. Yeah. Okay. We are still seeing your PowerPoint.
Can you see it now?
Yeah, we can see it now. We can see it.
Okay. Okay, sorry about that. So this is a dashboard, and then we have a web map in there, and the red and green points you see are the location of leakages, ones that have been repaired and those that are still pending. On the left-hand side is the leakage per material. So here we can see which materials have what percentages of leakage so far reported. Here we have the total number of leakages reported and what has been worked on so far. So out of a total of 41, we have 6 of them that have been currently addressed. And we can also have a chart that gives us, all of these information that you can, at a snapshot, have a window of. So just to end, I think we have, where is my, Okay. So based on what I've showed you currently, moving into the future, we want to make GIS more present in our operations. So we want to do more with the hydraulic models, developing more for our regional systems, introducing telemetry also in our operations. We have a few of those systems available, but to extend them as well and incorporate SCADA. But more importantly, we intend to share our GIS products throughout the company and make it more accessible to the user departments as well. So in conclusion, I would say that there are so many possibilities when it comes to GIS and its application, and we are only limited by the extent of our imagination. Okay, so on that note, I bring my presentation to a close.
Well,
thank you very much.
Thank you to Mr. David Nunoo. I'm sure if we're given more time, we would have gone on and on and on. But thank you so much. I'm sure you had to squeeze a lot within this short period, and we're really grateful. We intended to have the questions during the question and answer period, but I think we could just ask one, bring up a question at the moment for you to just answer quickly before we just move to the next speaker.
Okay.
Yeah, so the person is, this from Bright Anang. His question is, I want to know whether using GIS, you are able to determine newly developed areas which need to be provided water lines. Also, do you wait for residents to apply first, or you determine that these are areas where you can get revenue, and so you need to extend water to them?
Okay, can I take now?
Yes, please.
Okay, thank you very much. So his first question is whether we can use GIS to determine areas of supply. Yes, we can. And then we do that actually, as a matter of fact, we do use it. The challenge here has to do with the investments. And like I spoke initially about the challenges that we face as a company, one has to do with the money that we need to invest in extending or expanding infrastructure. And one of the challenges that was also mentioned there is the unrealistic tariffs regime that we run currently. So yes, we do it. In other cases, we also sometimes partner with the communities, and then we are able to extend our service to them as well. So currently we have an extent. We know the extent of our pipelines, and when we overlay this to where development has reached, we have a very good idea of where we need to extend or expand our services to cover as well. But that all has to do with money.
All right, thank you so much, David. And so thank you for the presentation.